Shall we start?
Let's get into it.
Okay. So, hi everyone. Welcome to CX Spatial Data Workshop. For those who don't know me, my name is Soja van Wichelen and I'm Deputy Director of the Sydney Southeast Asia Center. I'm very excited about this hands-on mini workshop on spatial data, which will be facilitated by our very own Dr. Sabin Zahirovic. But first, I'd like to acknowledge the Gadigal people of the Eora Nation on whose land the Sydney Southeast Asia Center is located, and from where I'm zooming in. I would like to pay our respects to those who have cared and continue to care for country. Now, it's my pleasure to introduce to you Dr. Sabin Zahirovic, who is a Robinson and Decker Fellow with the School of Geosciences. From his profile, we know that he's been a fixture at the University of Sydney, having been around since 2008 in various different roles. We're so proud to have him not only as a valued research member of SSEAC, but also as a key research advisor of our SSEAC Executive Committee. I just wanted to say that the session will be recorded and it will be shared afterwards with the group who have registered for this event. So not publicly, but just with our group. So Sabine, ready to rock and roll? Maybe you can tell the group how you'd like to approach the next hour and a half.
Absolutely. Well, Sonia, thank you so much for that introduction. Thank you for your leadership in SSEAC. You're an inspiration, and I love, SSEAC is like a family, so it's really fun to be part of. Simon as well in the background. Thank you for organizing all of this. Thanks everyone for carving out time for this today. Let's make it fun, right? This is all about like breaking down that barrier of like, oh, this looks too hard. It's really not. Don't let the geospatial scientists deceive you into thinking that it's really complicated, particularly to get started. The way I'd like to run this is really that you interrupt me at any time. So just yell out with the microphone. Put it in the chat. I might not be able to notice the chat, so might be easier to do through the microphone. So what I'll do is I'll start with a little kind of preamble just to get everybody thinking geospatially, what's the significance, right? Because I think there's been some incredible, dislocations and shifts in research in this space. So yeah, let's keep the discussion going. And this will just be, I guess, the start of a journey, right? You'll notice I'll feature a lot of the work from Associate Professor Eleanor Bruce here at the School of Geosciences. And, she's inspired me. I fell in love with Geographic Information Systems when it just, I guess, being part of her team. So anyway, let's get going. For anyone who's joined now, there should be some notes in the chat about like downloading some potential some data, right? QGIS, the data pack, and you can do that in the background as I'm just doing the introduction. So yes, thanks to SSEAC, thanks to the ARC as well, and I'd like to also pay my respects to elders past, present, and emerging. I am also broadcasting from Gadigal land here on the campus, Sydney Uni campus. So a little bit about me. I'm a geologist. I do a lot of, field work, but also actually most of my time is spent behind the desk at the computer, looking at this kind of geospatial analysis, numerical modeling and of Earth evolution on long time scales. And because we love Southeast Asia so much, this is just one of the models and animations that I produce. This is what is a deep time geographic information system. And you can see Australia breaking away from Antarctica and eventually colliding with Southeast Asia. And of course, that's what causes a lot of the natural hazards at the present. And it's changed climate and lots of other things. Now, of course, I mentioned climate. The current climate emergency is certainly not driven by the geology. It's driven by us and our behavior. So hopefully some of the themes that we can touch on today is like, well, how can we look at the vulnerability of regions like Southeast Asia in these contexts? Okay, so spatial data and analysis. I guess the most common term that people use is geographic information systems. And they're becoming really, really key in so many different parts of our society. I mean, most people are using Google Maps or Apple Maps. Google Earth and Google Maps actually started development in Australia. It's used a lot in the medical fields. I mean, we'll talk a little bit about COVID today. Um, resources, natural resources, tracking climate change, predicting climate change, looking at natural hazards, but even marketing, right? Like Amazon and Google and so on are tracking your location so they can, serve you ads based on your spatial footprint, So there's a lot of applications. There's been a huge rise in geospatial data acquisition. Australia has a new space agency based in Adelaide with a huge uh, priority on Earth observation. We can chat about that a little bit. But you've seen also, like in the last few weeks, months, the rise of artificial intelligence, which is becoming integrated with all this big data, the geospatial data. And so I think this is going to really open up lots of opportunities in research to tackle some of these huge problems. Now, um, cartography was kind of like a skill and science that existed for a long time, and it's since been absorbed into, I guess, geography and School of Geosciences and so on. And so geographic information systems are really kind of the new generation of cartographic tools. So it's a fantastic tool to have in terms of Sydney and New South Wales. There's a lot of job opportunities. So it's certainly a good skill to develop. And today, I think a lot of the discussion within SEAC and what we're trying to do is like, well, how do we kind of deploy these systems to help us meet the UN Sustainable Development Goals, right? And these technologies are enabling technologies that help us do that. And of course, Southeast Asia is our focus. It's a fascinating part of the world. Um, the other part of this is, uh, I've spent a lot of effort um, being parts of teams that are developing open community software. The idea of decolonizing, I guess, geology and other fields that have been historically, uh, you know, deeply rooted in colonialism, extraction, and so on. So today we'll be using tools and data that are completely free to anyone to use, right? There's no licensing, um, and you can just use it on any machine and in any way that you want, okay? Um, and you'll see, I guess, some of the examples of the software that exists that I'll talk about. So we've got just under an hour and a half. I'll talk about basics of geographic information systems. We'll jump into QGIS, the software. Um, we'll talk about loading data. What does the data look like? How do you bring in your own data? How do we create some basic maps and do some basic analysis? So this is really an introductory workshop. It assumes no prior knowledge, so please just jump in anytime I'm going too fast or missing anything. One of the things that struck me when I started with GIS platforms is that there's thousands of different tools, right? You don't be overwhelmed by that, because it's just about getting started, knowing where these things exist, and then over years you'll add different tools to your tool set. So let's talk about the history of GIS, and let's bring in John Snow. Sorry, the wrong John Snow here. This John Snow, who was a physician, and he was looking at the cholera outbreak in London. And what he did was he mapped all of the cholera outbreaks in Soho, I believe, in London, and he had a hypothesis that it was linked to a water pump. Now, this was actually pre-germ theory. There wasn't actually a clear idea of how cholera was spread. Was it through the air and whatnot? And so through this hypothesis, he he convinced the local authorities to actually remove the handle on this pump. And sure enough, it actually uh, killed off the cholera outbreak in this area, right? So it just highlighted how you can use mapping tools to identify a problem, make a hypothesis, and then make some changes, right? And that was an important part of the puzzle of developing the model for cholera transmission. Turned out actually that there was like a septic tank nearby this water pump, and of course there was cross contamination, and that's why people were getting sick. And of course, we've seen these sorts of tools here at Sydney Uni. Eleanor Bruce and others have been championing, essentially a 21st century variant of this tool to look at the COVID outbreak. I mean, many of us were looking at maps like this during lockdowns, during that very stressful time, to see what was going on in our area. Okay, so there's definitely lots of uses for this sort of tech. More broadly, I mentioned that we now have a space agency, and I think for Australia and the region, it marks a new era of Earth observation. There will be a focus to track bushfires, agricultural, and mining vehicles, automation, and mineral exploration here as well. You can see, but it'll be really important for weather forecasting, tracking natural hazards, and so on. So the rationale there was that it was actually cheaper to have our own space agency than to rent satellite time from the UK and the US. And the idea is that you could potentially have, say, a constellation of small, cheap satellites that could spot fires within a minute of ignition before they become, uncontrollable bushfires. And then you could launch a water-filled or whatever drone that would extinguish that fire within a few minutes, right? So it's kind of adaptation to this new climate state that we have engineered for ourselves. But in terms of other trends, there's in terms of geographic information systems, I mean, everyone's looking at the autopilot in self-driving cars. There's lots of geotagging, importance for navigation, uncrewed aerial submarine systems, drones. They're getting lots of use, from delivering your lunch potentially to use in war zones, which is, it is what it is. But there is also this really interesting link with high performance cloud computing, big complex data analytics, artificial intelligence, and mining this data to extract more knowledge, and lots of other kind of trends there. So let's kind of step back and talk about some of the basic underpinning concepts. Today we'll be talking about spatial data and geometries, whether it's points or lines or polygons. And they're most often recorded in some sort of series of longitude and latitude points. Okay, so we have our planet, we've got lines of latitude here in blue, and then the longitude are these, what we call these great circles, right? And just kind of refreshing everyone that, the prime meridian that goes through Greenwich is 0 longitude, and that goes east, it goes positive to 180, and west, it goes negative to 180. Okay, this is what we call the anti-meridian on the other side of the planet. And we've got minus 90 to 90 degrees in latitude, okay? And your GPS, as you walk around it, it's looking for a constellation of satellites and triangulating your position and recording that position. And so that's how we've been collecting all sorts of data. And of course, satellites can map whole swathes of the surface. There's lots of other technologies, but this is just a kind of basic example. So for a lot of the data that you'll need to put into GIS, you'll need some latitude and longitude information. And the most common way that this is encoded is in this World Geodetic System datum, WGS84. You might come across that today. And that's really just the latitude and longitude that we're very familiar with. So this is in terms of GPS, you've got your device. Um, it's looking for multiple satellites and figuring out their distances and triangulating your position. Horizontally, you usually get about a 3-meter accuracy, lower accuracy vertically. So it's just good to know, I guess, the shortcomings of that accuracy. I know for myself, I remember being in the field, getting very excited, taking measurements in the field, but not waiting long enough for the satellite fix to get an accurate reading. And so like a few days of data collection, I had to go back and redo properly and wait for that accuracy to increase. But you learn these things along the way. There are much more accurate ways of getting positional data. So these kind of real-time kinematic systems with positional accuracies of sometimes millimeters, usually a few centimeters. So when we're um, uh, uh, looking at coastlines and the effects of storms, we're usually mapping at these sorts of accuracies.
Sabine,
Yes, Sonia.
how did you know it wasn't accurate and you had to go back?
Um, I realized that when I just opened my phone and took a measurement, I saw the GPS location. But then if I kept it on, there for a minute longer, it would kind of shift, to its more accurate position. So this is
Okay,
how like it can be very deceiving. You think you've got a position and you get the numbers, but it's probably 20 meters off, right?
great,
And
thanks.
so it's worth keeping in mind. Because yes, so most GPS handhelds and your phones, they 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 get you a rough position first, and then over a minute or so, they get you a tighter fix spatially. There are other ways that geographic data is encoded. It's still latitude or longitude, and technically they call them northings and eastings in this universal transverse Mercator system. This is often for very high resolution things. So on the Padlet, someone mentioned apartments and cities and your streets, your councils. They're working in these UTM zones where um, you know you need to be aware of where you are in the world, in this which zone you're in. And the idea here is that it's trying to minimize the distortion, right? Each one of these systems is simplifying the Earth. We think of the Earth as a sphere, but it's kind of more like a lumpy potato with the distortions in places. And so the UTM system, for example, it records things in terms of eastings, and the units are meters east and meters north with respect to some reference point in each of those UTM zones. Okay, I'm just highlighting this because you'll encounter different different ways, and it's very important to know roughly what you're dealing with. Your geographic data here is in degrees, decimal degrees, latitude east, sorry, north, or south and east west. But here it's like meters. So it's worth keeping that in mind. In terms of when we're actually making maps, there are hundreds and hundreds of map projections, lots of different projections, and they're all trying to do something. They're all trying to typically reduce distortions, because what you're doing is unfolding the surface of the planet onto a flat piece of paper, right? And that is very, very difficult to do. And so some of the projections, particularly some default projections that you get in software, have some serious distortion. So you get these sorts of things like the Mercator maps, where Antarctica looks huge, but it's not. It's just the way that the higher latitudes are kind of expanded and stretched out. Um, the reason I say that is as you develop your skills, you'll be able to choose the best projections for what you're trying to deal with, right? So, for example, right, some projections uh, preserve equal areas, right? Okay, so they might screw up distances, but they will stay true to the areas of things that they represent. Some are what we call azimuthal projections that preserve azimuths and directions, but compromise on the areas and computation. So, again, details that you can kind of just put at the back of your mind, and just that in case they ever come up, you'll be a bit more familiar. Here's just an example of the distortion on Mercator maps. This is a circle at the equator where there's least distortion, and as you go further north, you can see there's much greater distortion there. When you try to match different projections, you can see how different and offset things can get. And really, the key thing is that you want to make sure you're plotting everything in at least the same projection. Okay, and most of the time, the geographic information systems will happily do that for you. So here is another an example. You can see in the Mercator maps that you're often faced with. Greenland looks enormous, right? But when you actually reproject it to equatorial latitudes, it's the size of smaller than Indonesia even, right? So this is how maps can kind of introduce some biases, and so you want to try to reduce those as well. Now, I kind of started with talking about tectonics and how Australia is moving at about 7 centimeters a year. Well, the interesting thing is that we have these reference points, these datums, and well, if it's 10 years goes between any update of the datum, well, that's 70 centimeters that something has moved. And now that doesn't really make so much of a difference of where the volcano is, because the volcanoes you'll be able to see it. But if we're talking about pipes and um, uh, you know uh, electrical things, or even self-driving cars, you don't want to be 70 centimeters in someone else's lane. So just in the last couple of years, there was a big update of the Australian datum, the GDA 2020, and you can see the difference here since yeah, the last update, almost 2 meters. Okay, now the University of Sydney provides us with proprietary commercial software from Esri. So many of you might have heard of ArcGIS. It's funny enough because they have lots of different pieces of software that even software to design airport layouts and so on. So you can get very creative with this stuff. The problem is that for any one license, any one individual, the license can be up to like $4,000 US per year, and the software is Windows only. Now, if we're trying to democratize the science and access to all of these tools, it'd be better to use something that's free and open source. And so thankfully, we do have a bunch of free open source tools that are actually really good and very mature. And the one we'll be using today is called QGIS. Okay, so it has almost the same functionalities of ArcGIS Pro. Okay, so it is fantastic. It uses an engine under the hood called GDAL, and this other thing called GrassGIS, which is a bit older. So yeah, it's a very it's the standard community geographic information system. The animation I was showing before of the tectonic movements I made using generic mapping tools, and that's more, when you get a bit more advanced with like coding up and processing data, with scripts and stuff. But it's also a fantastic tool to keep. Yep,
Sabine, so
sure.
why would you use, sorry, I'm just curious,
Yeah.
why would
Yeah.
you use Esri instead of QGIS?
Yeah, this is a question, Sonia, that comes up all the time, particularly like students, right? We should be trying to teach our students to have this open science, open philosophy. But the reality for us is that all of the industry is using Esri. And the reason they use Esri is that Esri has, because you pay for that license, they do offer some technical support. And, I would say it's pretty crappy support, to be honest. Um, but that's what people are really paying for is potential support, and that, if their software misaligns a water pipeline by, you know, 20 centimeters, well, they could probably sue Esri, whereas they probably can't sue QGIS because it just says, look, this is scientific software. It's good, but every so often you'll notice bugs. And actually, what I find hilarious is that uh, ArcGIS has so many bugs. Um, just the color palettes on maps are atrocious. I have lots of funny discussions with colleagues in industry who, yeah, equally shake their heads and are equally frustrated. But the other advantage is that QGIS runs on Windows, Linux, and Mac without any issue, whereas ArcGIS Pro will run only on Windows. And so I do actually have it on my Mac. Um, and to be completely honest with you, I am more comfortable with ArcGIS just because I've used it for much longer. But I'm trying to break away from that myself. Um, and yeah, I find QGIS very, very powerful. Any other questions so far?
Yes, just have a
Yeah.
question.
Yeah.
So I work with map using R mostly with the
Uh-huh.
S package. I'm not sure if you used that before. Yeah, just wondering, what do you think QGIS is best for? Like what type of, I guess, yeah, data or work,
Yeah.
compared to the other program.
Yeah. So that's a great question. So QGIS and ArcGIS are really fantastic for making a map at the present day, doing some of those interactive um, um, analyses through the graphical user interface, right? But as soon as you're crunching huge amounts of data, uh, I would recommend, as you've probably found, that R and some other tools become much more useful, because the issue is like both ArcGIS and QGIS then have to load up millions and millions of individual points on your display, and you'll see even today when we plot the hurricane tracks, it slows down. So I find that R and scripting with GMT, it's really that next step. It's like, okay, I've made a nice map with QGIS, but I'm really trying to um, mine this data, through a script, if there's lots and lots of data to crunch, if that makes sense. For me, for example, generic mapping tools does this similar thing as you described with R, um, and I need to create like thousands of maps, and all that's changing is the age, right? And so it would be really painful to do that in QGIS and ArcGIS, to manually make those maps 1,000 times over, right? Um, but yeah, QGIS and ArcGIS I really like because you can see what's happening. You can try the different tools and processing.
Okay, thank you. Great. Good to know.
Yeah, great. Any other questions? No? Okay. Yep. So geographic information systems are kind of underpinned by really two types of data, which is raster data. And so you can think of that as like pictures that have cells with some value in them, or vector data, which are usually points, lines, or polygons. Okay, so you will see that distinction today, and it can have a temporal component, and which we won't have time to discuss today, right? It's a bit more advanced. But the interesting thing with the data that you might come across, when you're downloading it, the industry standard, again, this is an Esri standard, but it's used everywhere. They're called shapefiles. Okay, so shapefiles contain just geometries. So they can be points or multi-points, lines, or polygons. And the annoying thing about shapefiles is that they can only contain one type of geometry. Okay, so if you're looking at apartment complexes, you might have polygons for the suburbs, but then individual points for the addresses, and so you'll have to keep them in separate shapefiles. But that's just a minor technical thing. And then the raster data is often provided as GeoTIFFs, or geographically tagged image format, ERDAS imagine files, netcdf grids, and so on. And you'll start encountering these as you start plotting things up. Okay, now this is probably a slide I recommend that you kind of like, I don't know, print out or come back to, and I'll share these slides as well. Some of the main tips is that when we start building a project of Southeast Asia, of Indonesia, you create a project file, a map project file. They're very small files, right? And so you can say, okay, I want to send Sonia, this project, but if I just send that little project file, that's not going to be any use to Sonia, right? It doesn't actually contain the data. It just contains the instructions on how to draw that data that exists in the folder. Now, shapefiles, they have a file extension .shp. They have a bunch of accessory files as well that need to be kept together in the same folder, right? And that's really important. I can say, oh, Sonia wants a shapefile, and if I send Sonia this file alone, again, it won't work. It needs to have all the other files. If I rename the shapefile, I need to rename all of the other files to match, okay? If you've created a project already, you don't want to be moving or renaming those files outside of that working folder. The software won't know where you've put that data. Another thing that trips up new users is that none of these softwares can look inside a zip compressed folder. So I sent you a data.zip folder. We'll need to uncompress that and use that. I'll talk a little bit about relative path names once we get going. And the other very interesting thing is you want to try to avoid very long file names or spaces in file names or starting file names with numbers, symbols, and so on. Particularly like the Esri ArcGIS software gets really, really angry if you try to do any of this fancy stuff, which we do every day. Sometimes when you're working in a directory in a folder, your GIS tool might create a new temporary file somewhere else on your hard drive. You want to make sure that you save it into your working folder, because then you can actually zip up that whole working folder and you can send that to Sonia. She'll be able to open that up and all of the data, everything will work seamlessly. Another tip is just keep backups in the cloud, OneDrive, Dropbox. And the other thing is keep a record of where the data was downloaded from and even the date that you downloaded it from, right? Because databases get updated. You want to know, you'll come back to the data 3 years down the track and you'll want to know, where did I actually get that, shoreline data or the hurricane database and so on. So I've created READMEs in all of this.
Sorry,
Okay,
Sabine.
so yes.
To record those dates, is that also important in terms of citation for publications or not? You don't have to cite your data.
It can often be really important because databases keep updating. So for reproducibility, you actually want to know what instance of that data you were using. Great. Okay, so let's get started. Hopefully, most of you managed to download QGIS. And so I'm going to share my screen now, actually, and just jump straight into QGIS and getting started. Okay, so I sent you that zip folder, okay, and you want to make sure that it's unzipped, okay, whether you're on Windows or Mac or Linux, okay. So you'll end up with a bunch of folders self-contained in here. Each one of them will have, you know, a shape file or some other files and a README, and that will take you, you know, to where that was downloaded from. And so what we'll do is we'll progressively add these different things to QGIS. So I'll just launch QGIS. Has anyone had any problems downloading and installing QGIS? No, it worked for most people. Okay, so let me just hide my floating controls so I can actually see my whole screen. Okay, so this is the interface. There's some, you know, obvious buttons up here like new, open, save, and there's a bunch of other things that we'll discuss. One of the first things I recommend is that we can just we can save a project. Okay, so let's just save that. I'm just going to call this Sabin. Sometimes I like actually putting like the date, and you'll see it'll create this file, a QGZ file, and that's just a project file. Okay, it doesn't actually contain the data, but we're going to build this out. One of the important things I'd like to point out is these relative or absolute paths, and that information lives under project and then properties. Okay, so if you go project and properties, there's lots of different options and things here to choose from. But really, the main one is general up at the top, and make sure that save paths are relative. And I think that's the default now in QGIS, but you know, just in case anything breaks down, that's relative. The reason I say that is if I use absolute paths, I can zip up that whole workspace, that whole folder, send it to Sonia, and it still wouldn't work, okay, because it's looking for the absolute paths on my local hard drive. This is just going to now look for the relative paths. So, well, let me just, whoops, I want a list. So this is this project file I've created now, and it will use a relative path system, look inside data. So let's load our first data in. And what we'll do is we'll just drag some stuff onto here, this table of contents or layers panel. So let's go into this folder called GMRT topography. This is what we call the global multi-resolution topography from the space shuttle and other things. And you'll see here, it's the TIFF file, and TIFF files are images usually, and it's a GeoTIFF, so it has some geographic encoding and tagging. So if I click and drag that onto here, it will create, it will show the raster, okay? Has everyone managed to get something like that in their display?
If it's going at all too fast, let us know and then we'll go back.
Yeah.
Sabin, can you hear
Yes.
me?
Yeah, I can.
I was trying to ask a question before and it didn't work.
Oh,
I think that's my fault, not yours.
Yeah.
With that README file, you just
Yes.
went through that very quickly. What was
Yes.
that?
Oh, it's just a little note to myself being like, if I come back in 3 years, like, where the heck did I get that data from, right?
Okay, so that could be like a Word document.
It could be a Word document. It could be anything, yeah.
Okay, all right. Okay.
It's just
All
some
right. So
notes
this
for
is like
yourself.
your source that you're keeping a track
Yeah.
of. Okay.
Yeah.
Thank you.
Exactly. Yeah. Okay. All right. So let's then load up things like, let's see, uh, Indonesia admin boundaries. If we open this folder, you can see lots of different files, right? But there's really only two shape files in here. And the difference is ADM0 and ADM1. And that's just the level of administrative boundaries. It's just the system that they're using. So if I drag those onto here, you'll see a map, a political map of Indonesia, the whole country, and then the other one is the provinces themselves. Okay, so hopefully that worked for
So
most
do
of
you
you.
mind going back again on how to get that?
Yep. So you need to find the SHP file, the shape file, and then just drag it onto the layers panel here. Did that work?
Yep, I got it. Thank you.
Beauty. Excellent. Okay. So you can already start to see how this works. It's kind of like a layer cake, right? The things at the top of the list appear on top, okay? And you can untick them, okay? So you can hide that layer. And then you can rearrange the layers, right? So I can click and drag up and down that list and rearrange that ordering of rendering. And so that's one thing that might trip people up initially, is sometimes you might load in a raster and it just like it's sitting on top of everything and you don't see any of your data. Okay, so let's keep going. Let's have a look at some stuff. We've got cities. Let's check in. Oh no, let's leave the cities for a minute because this is a good example of your own data that you might want to bring in. Let's bring in volcanoes. I love volcanoes. So again, look for the shapefile. Bring that in. You should get some dots. Then we can look at earthquakes. Okay, again, this shapefile of earthquakes. Now, you'd be like, well, what the heck's the point of talking about earthquakes and volcanoes in the context of COVID? But we'll get there. We'll talk about vulnerability of areas. Let's bring in the cyclone tracks. Okay, Archive of Global Tropical Cyclones. Can bring that in, and what you'll notice is that this will actually slow things down a lot. I think Chi, you were asking about like, okay, what's the benefit of using R? The plotting in R will be usually faster when you're dealing with very large data sets. So I'll bring that in, but I'll just hide it so that it doesn't, keep re-rendering and freaking out. Okay. I think this is.
Ben, how do you zoom out?
Okay. Very good question, Sophie. Thank
Yours
you.
is different than mine. It's different.
Yes, excellent questions. Okay, so let's talk about some basic controls of the view. Okay, so click and drag when you've got this little hand icon. That's just to pan. Okay, now to zoom in and out, you can just use your scroll on your mouse in and out. Okay, I think you can use the magnifier here, and then there's like specific tools up here. One really, really useful trick is, you might be like off the page somewhere, something's gone, you're in a random spot. And to quickly get back to your data, you can say, okay, I want to zoom to the extent of this thing. I can go right click and zoom to layer, and it will auto adjust. Does that help?
Mine doesn't work, but I don't, that might be just computer says no. Anyway,
It
it doesn't.
I wonder if it's your mouse thing. I don't know. So yeah, you click and drag will move things around, and then these tools should allow you to zoom in and out. Is anyone else having problems? Because, you know, software can have glitchy things. Sophie, does any data show up though?
Yeah, I've got data. I just can't figure out how to zoom in and out, but don't worry about it.
Okay, I'll come by later and we can zoom in and out, hopefully. Okay, so yes, so zoom to layer. Okay, so we've got some data and we're already building a project. I can, you know, what I recommend is you keep clicking save and make sure that you have those changes saved. Okay, so let's just talk briefly about some basic symbology, right? You know, in any cartography, you want to be able to distinguish between, you know, your cities, your earthquakes, and you know, volcanoes, right? And that can be quite useful. So let us look at the volcanoes. Okay, so we can right click on the layer and go to properties. And again, there's lots of different things that you'll be able to deal with later on, but let's just jump to symbology. And so symbology is essentially, it controls, yeah, that symbol. And you can choose from some of the presets and then modify it, including their size, the color, transparency, and so on. I kind of associate volcanoes as like red triangles of some sort, and I can click on OK or apply. Oops. I think if I click on apply in the background, it would have updated it there. Okay. You can then change the size. If I click apply, it will change that size. Okay. So can everyone see those red triangles? It's all the volcanoes in the region.
Sabine, there was a question from Alicia.
Yeah.
How do you get the processing toolbox, because it disappeared on her?
Oh, the processing toolbox. Yeah, good question. I am every so often it disappears on me too, and I I have to figure it out. I think it's just this button up here, toolbox, Command T or Control T. Yeah, we won't need the processing toolbox till probably later. So, but yeah, the main one is like often when if the layers disappears, I tend to have a little panic attack because I always have to figure out where it's gone. But yeah, so layers is the most important thing at the moment. Okay, so now let's look at symbology that's a little bit more complicated. Let's look at our earthquakes, currently all of these dots, and let's color them by the magnitude, right? How strong the earthquake is. Or maybe we'll do something even more interesting. We'll color by the depth, maybe, and the size by the magnitude. Let's get into it. Let's have a look. So we go right click and properties. And again, symbology, the tab on the left. And so again, you can choose a single symbol that applies to all of them. But now we can do something like, say, graduated, okay? And we can use some kind of value that's embedded in that shapefile. And I'll talk about those in a moment as well. If we look at the drop down, we have mag or magnitude. So if you think of the Richter scale, that's what it is. And so if I click on this button called classify, okay, it will just classify the magnitude distribution based on, you know, these classes that you've set here. So default is always 5. I don't really know why. But if I click on, if I type in 10, it will recompute. You can, again, this might be a little bit fast and you can come back to it, but you can do like an equal interval, okay? Change, you can do all sorts of fancy things like standard deviations or natural breaks, classifying, I guess, these sorts of things. But if I click on OK, you'll see that the different, the earthquake dots now have, you know, different colors. I can expand that now and see that allocation. Now, this is a terrible map because the colors are starting to clash. So I can go back and change the color ramp to something else. Okay, maybe some blues or something like that. And say, oh, okay, well, I'm not, I want to actually invert that. Where is the, for whatever reason, oh yeah, invert color ramp. Okay. So the darker those points, the stronger those earthquakes.
Sabin,
Yeah, Jared.
I've got a question about that particular color ramp, the natural breaks one. Is that the one that you're using?
Yep.
So why has it put the range 0 to 5 as the second lowest rather than the lowest category?
Yeah, I don't know actually. That's quite odd. I don't think it. Yeah, that's really weird. It's just done that. I think it's also part of the way that it's looking at the histogram. So it's like finding the, you know, the ordering of things. So let's go back to equal interval. And then, yeah, you'll see that it becomes more sensible. And the reason why I don't have any values less than 5.5 here is because there's so many earthquakes of, you know, less than 5.5, you know, we'll be here all day just loading that file. Okay. One of the other things you can check out is, let me just see. You can play around with this maybe later. These rule-based sorts of options, but graduated. I just want to see. Yeah, the other option on the graduated is size rather than the color. Okay, and again, if I classify the magnitude, okay, what it will do is plot the earthquakes based on their size. Okay, so the smaller circles are low magnitude earthquakes to, you know, very high, very strong earthquakes. So yeah, you can get quite fancy with the symbology. You can then say, okay, well, I want the templated symbol to be slightly different. I don't know. I want a different color of green. I want, you know, maybe I want it slightly transparent, and you can change the outline, color, and so on, thicknesses. So here we go. Stroke width. Increase that. Click OK and click OK. All right, and so then it changes that automatically for you. Is that kind of making some sense? So the key is that you can go to any one of these layers, right click, go to properties, and then apply some coloring. and symbology. Now, you might ask, like, oh well, where is it actually getting the magnitude from, right? And it comes from the attribute table. So any one of these things has, if you right click and go to open attribute table, each one of those geometries has what we call metadata, right? It's some additional data linked to that position and that geometry. So it could be, in this case, it's time when the earthquake happened, its position, the depth, say in kilometers, and the strength, magnitude. Okay. Similarly for the, I'm not going to open the attribute table for the hurricanes because it was taking ages yesterday when I was testing it. So I'm just going to go to the symbology, and I can, again, we can try a slightly different one, which is categorized. And the value here can be season, which is year. Okay. And if I just go click on classify, it will go through and try to, identify all of the seasons. Okay. And we'll color those like that. So you get like lots of spaghetti, which are the cyclone tracks. What might be easier is the graduated and color-based thing, season, and then applying some color palette. Sure, magma. We can flip it. In this case, I can classify this as well. It takes a little while again because it's a very, very big data set. So let's just wait. Okay. Click on OK. You'll notice if I expand that, the more recent hurricane tracks are plotted in this kind of dark or black line. And again, because of this, you can choose to hide certain aspects of the data, rearrange it. You can say, oh, I can't really see Indonesia anymore. I can move Indonesia up, but to still see those earthquakes, I can go to properties and again, in the symbology, I can just change the opacity, right? The transparency. Set that to 75. Okay. So these are kind of the basic tools of symbology, rearranging things. I mean, Sophie, thank you for bringing up the, the aspect of moving things around, zooming in and out. Any questions so far?
Sabin, where would you get this kind of data if you wanted to plot something?
Yeah, that's another excellent question, right? So over time, you'll get a bit more familiar with looking for data, right? So there are some repositories that have data. So this is, I think, from the UN, the Humanitarian Data Exchange, and it's got lots of different types of data. When you look at some publications, they'll say, okay, this data is stored on Zenodo or some kind of or GitHub or some other place. Another way is to just Google it and put in the right keywords, right? So we can say Indonesia population density grid GIS. We can get specific in GeoTIFF. And then you'll have to look around. Sometimes you won't get the perfect thing immediately, but yeah, you might just have to download it and try it. Essentially, that's how I do it.
What would you be looking for in terms of like what's the word, like verifying it as good data? Like, how would you know?
Yeah. Yep. So verifying it in terms of good data, you want to make sure that the metadata, makes sense, that it's got a, it's tracked of where the heck it's from. Is it published as part of a UN report? And so you can see here, for example, the contributor is data for good at Meta. So it is Facebook data, but it is, there is attribution for it, and there is a methodology, and you can actually, go and have a look. And then you have to decide whether it's, reputable or not. But that's a really, really good question. Another thing that people might be interested in is what we call open street map. So it's like you've got Google and Apple Maps, but their data is proprietary. You can't just download their streets and cities as shapefiles. But there is this thing called OpenStreetMaps, and you can navigate to any part of the world, and you can essentially download all the streets and suburbs and so on in a box. So that's one way. And in terms of shapefiles, well, you can say, okay, shapefile, earthquakes, global something. Okay, and then you might want to go to the USGS or well, the World Bank and so on. Okay, so that's kind of like places you can start looking at, but you'll get more confident with some of the typical places to look for specific data.
Following up on that question,
Yeah.
How do you know what is good data? Are there any characteristics when you like definitely think, no, this is not data that I should be using because it's just, yeah.
Yeah, look, most of the time it's very obvious. So for example, if you're really trying to use something in research, if there's no attribution of where it's from, how it was collected, you've just got no clue, right? You have no idea of the source. It's impossible to cite. So yeah, those are the obvious ones. Then you can have lots of other things, which may be like gray data, like gray literature, which is published in some reports, but maybe it's not peer reviewed, and then you have to make a judgment call. It's like, oh, is this the highest quality data that I can get for this, or can I get something a bit more, that something that's cleaned and calibrated and peer reviewed and really scrutinized and so on, right? So we certainly have that in geology, for example. People are talking about these paleo digital elevation models, like what was the Earth's elevation 100 million years ago, right? And there's a model that is kind of gray literature, but everybody uses it, and nobody knows how it was constructed, right? What data went into it, what method was used. But sometimes you kind of have to accept, like, okay, well, this is where the state of the art is right now. How do we move it forward? How do we make better resources? And that's why it's so important. Like when you're actually, the way I try to do it is like, okay, I create some models, I create some data, I make sure that it's well documented, explain exactly what units are there, what projection system it's using, and anything else that helps people with reproducibility. Right?
We've got a question from Peter. How would you get in your own sets of coordinates or shapes and analyze it?
Beautiful. That's exactly what I was going to do next. So thank you for getting us to that. So let's get to cities. Okay. Now, these world cities come in a table, and you'll notice that it's in an Excel spreadsheet and a CSV file. CSV files are comma separated value files. The reason I say that here is that QGIS and ArcGIS don't like XLSX files. They don't like these new Excel files. I don't know why. I think it's a licensing issue. So, you know, we tend to work with these old school simple text files. You know, you can see it's comma separated, comma delimited. The cool thing is that if you just double click on it, it will open up in Excel and look like a spreadsheet. If you've got your own spreadsheet, well, you can just go to File, Save As, and choose CSV, comma delimited file. Okay, so I can just I'll do that, right? So you just demonstrate that, you know, that's exactly what I'm doing. So Peter, there's some key things to remember with bringing in things. The formatting, you can forget formatting because these are just simple text files. You need to have a row, which is your column heading. Esri, despite being the world leader and having probably billions of dollars, they're still kind of stuck in the dark ages, and they want very short, succinct column names, okay? And usually spaces and special symbols are a no-no, okay? Or a column name that starts with a number, or, you know, a symbol. Now, this sounds frustrating, but it's just the reality. QGIS is far more flexible and forgiving, but, you know, it's just good practice that, you know, if you're sending some stuff to a colleague who might be using ArcGIS, they might have some issues. So this is a database of all cities, and you can see the key thing is that you want to have some positional data recorded in here. So you can, I mean, you know, maybe you want to plot up your holidays, you know, of Southeast Asia, or like the volcanoes you want to go visit. You can use your GPS on your phone or somewhere, or you can just go to Google Maps and you click on anywhere, and it will actually report you the latitude and the longitude. So it's very important that you distinguish between the latitude and longitude, and make sure that they're within those bounds of -90 to 90 for latitude and -180 to 180 for longitude. Sometimes the software freaks out if they're outside of those bounds. Any questions so far just with the table itself design? No? Okay, so if I go to QGIS, there's lots of different options up here, and I sometimes get myself lost. So one of the tips is if you just click on help, the drop down here is a search, and then I just start typing delimited. So this tool lives under layer, add layer, and add delimited text layer. I can just click it here. Okay, I can then point to that. Where is it? Here it is. Okay, that comma separated value file here. Oops, I pressed the button too quickly. Before I click on open, I need to actually specify where the latitude and longitude lives. So the point coordinates are X is longitude, so that's your X axis, east, west, and Y is latitude. Okay. And I can click on add and close. So I'll go through that again. Go in this search function under help and just type in delim, and it's under add layer, add delimited text layer. Go into that data folder, and it's at the bottom, simple maps, world cities, basic. and point to the CSV file. Click open. It might be hiding behind the window, main window, and then specify that latitude and longitude, or longitude and latitude. Okay. So that's one way you can bring in your own data. If I right click and go to open attribute table, you'll see that that whole, all of that has been preserved. That whole table from Excel has been preserved. So now you can say, okay, well, I can just color by the population. Right click, properties, graduated, population. I click on classify, and okay. Okay, so that's bringing in data. Let's bring in some COVID data in a similar way, and do some kind of first, you know, analysis and make use of these tools. So I'm going to just hide a bunch of things, so it's a little bit neater. I'll keep my Indonesian provinces, and I'm going to add a delimited text layer, and it will be under COVID data, and it will be this IDN dash something CSV file. And so what it is for the 15th of September 2022, it's the COVID data by province. Okay, and it has everything from like new cases, you know, total cumulative cases, you know, death rates and so on. And so you can see in some places it might get a bit dicey because there's spaces and whatnot in the column headings, but it should be fine. Let's live with this for now. But you know, it's useful because it's got the longitude and latitude here as well. And we'll do something a little bit fancy with the GIS as well. Okay, so again, I go to add delimited layer. I point it to the COVID data IDN spreadsheet. And it's annoying because it hides behind the main window. I bring that back to the beginning. And it's actually detected the X field and Y field as longitude, latitude. I click on add. I click on close. Okay. Did that work for most people? Great. So let's click the save button. Take a breath. We're getting there. We're building a map. The next thing we're going to do is something a little bit fancier, right? Which is we're going to do a table join from the provinces shapefile. And this data, which is point data, we want to actually propagate those COVID data to the province polygons, okay? And the cool thing is that you can say, okay, well, this is the location, this is the province name, and as long as the province name is spelt the same way in your other data set, then they can be matched together, okay? So if I right click on my provinces polygon file, I go to properties, okay? We don't care about symbology at the moment, but we want joins, okay? There's nothing there, so we click on add new join. The join layer is going to be this new IDN, you know, Indonesia table, okay? The join field will be, and I always have to look this up. its location. Okay, so we're going to base it on the province name. So location. The target field is, in our case, ADM1_EN, and you'd be like asking, like, what the heck is he talking about? And I'll show you in a sec. In the attribute table of provinces, you can see there's Aceh, Bali, Anten, and the column name is ADM1_EN. Okay, so we're joining those two tables. The cool thing is when I do that, if I go, if I open the attribute table, you can see that it's now added and appended all of the other data from the other table to that map of provinces. Is that making some sense so far? Yeah. And so now, before this was a pretty flat, boring shapefile of just the provinces. Now it has data about COVID in September of 2022. So now I can go to properties, symbology, and I can actually use what we learned before, which is look at the value, say total deaths, and we can do classification, click OK. And so you'll notice then something, right? You'll notice that these provinces along Eastern Kalimantan or Borneo and Java have had the highest deaths, okay? You can then have a look at other things. You know, you can activate your earthquakes. You can say, well, there's probably not a lot of, you know, earthquake hazard here, but, you know, there's a lot of earthquake hazard on Java. And so you've got earthquakes, you've got COVID and high populations, you've got probably some effect of hurricanes. If I, where are my hurricanes? Oh, here, I've just hidden a whole bunch of them. Right, and so like, you know, you can start kind of seeing that you've got areas that might have multiple vulnerabilities, and you can start thinking about those sorts of things. I wanted to spend the last 10 minutes of us actually going through and actually creating a map that we can use in a paper. So we'll do that. But this next thing I wanted to quickly demonstrate is just highlighting where, for example, a coastline might be if sea levels were to rise. So I can just, again, type in contour. I'm going to contour the topography. Intervals is going to be a large number because I just want one contour. And here you can say, well, sea levels could rise by 8 meters by 2100. If the geologists are right and say that we might get into a greenhouse climate state, well, sea level might actually rise 80 meters, which is pretty scary. It's worst case scenario. If I click on run, I don't know why that didn't work actually. What's going on? Change parameter. Elevation. Oh, it does not want to work for me today. I'm going to leave it. It was working yesterday. Okay, so we've made some maps. We want to make a publication of this. We want to print this out. And to do that, you actually need to create this a map print layout. So it's this button here, new print layout. Let's just call it whatever, Indonesia, and click OK. So this is like your blank page. This is your blank canvas. And so now that we've got all these basic things, we can then add the map. So there's a little button called Add Map. I can just draw something, okay? and it will add that map. We can change the zooming level a bit. Sorry, my laptop is not cooperating. Oh yeah, okay. Okay, so we've got the basic map here for now, all right. But we want to add other things like the legend. That's really, really easy. So we can click on Add Legend, draw a box, and it populates all of our legend and symbology. Okay. You can, for example, disable things that aren't shown. So for example, only show items, the current map. Let me see. Yeah. It becomes a bit smaller. Oops. You can then add some text. Oh, here, sorry. My first map. Okay, change the fonts. Look, there's so many things to play around with. I'll just leave it there. We can put in a scale bar, right? We can put in north arrow. You can put in lots of different things, images and whatnot. So one thing I'm noticing is that the earthquakes are becoming so dominant. I can just turn them off for now and click on refresh. And so I get a cleaner map. I can add, I think the most important thing at this stage is to add the gradicules, the latitude, longitude positions. And so I have to remember how to do this because it's very different to ArcGIS. So now you're all testing me. Properties. Okay. Extents are good. And then I believe it's this grids. I think it's grids. Modify. And I'm going to put the interval here as every 10 degrees east. 10, 10. So it creates that grid. And then there's lots of other options about, labeling the coordinates. Format, we could say, okay, decimal. The precision you can drop down to 0 and so on. Okay, so you've got this map. You can, whoa, it's gone. In the back here. We want to save it and we want to export it as a PDF or JPEG to print, for example. So here is export as image. And there's Indonesia. You can change the resolution, crop to the content if you want, and save. I can do the same for a PDF. So hopefully, yeah. There's your first map. So you can play around a lot more with, the symbologies, the labeling, the zooming, the color scale of the topography and whatnot. But I just wanted to get people a little bit familiar with some of these, concepts. And if I've saved that map, what I can do is I can now just double click on that and it will load up QGIS with all of those things linked, and you can start off where you left. So you've got a digital workspace and you can modify that very easily. So again, zoom to layer, and there you've got it. Okay, crash course, but hopefully that gave you an idea of how this is done. Next year, we can go into more detail. We can actually show you how you can edit and digitize things and, add data that way. But I'll leave it there, and yeah, happy to take any questions.
Sabine, this was amazing. Someone, as an anthropologist, a cultural anthropologist with no clue, it was totally demystifying. It was so useful. Thank you so much, Sabine, for an amazing session. And as Sabine said, we started this as a sort of a pilot, and hopefully next year we can run a few of these sessions to go deeper into how we use these tools in our research, or how we can interpret how people are using these tools. I'm afraid we don't have too much time anymore for questions, but please join me in thanking Sabine for this excellent workshop, and hoping to see you soon next year for a similar series of workshops. Thank you, Sabine.
Great. Thanks, Sonia. Thanks, team. Have a great week ahead. And yeah, use the Padlet or email me if you've got any questions, and look forward to seeing you at another workshop.
Awesome. Bye, everyone.
Okay. Bye, team. See ya.